Yes, we can see it, engineer.
Okay, yesterday we finished at big data sources. So today we are going to complete the big data analytics lifecycle. Just a second. Okay, so today we are going to do 7 to 10, and as well as slide 2, which is chapter 3 and 4. This is chapter 1 and 2. We'll complete this and start on chapter 3 and 4 in the second hour. Okay, so when you embark on a big data project, there is something that is called a big data analytics lifecycle. Just like any other data analytics lifecycle, there are certain rules that you have to follow, or there are certain steps that you have to follow, or a syntax. If it's a code, there is a certain way of doing things. You don't just embark on a project and just start doing it anyhow. Even if you have experience doing things, it's always best to stick to the base principles. I know inside this class, there are a number of people who are already doing data analytics in their organization. But what I've learned over the years is no matter how much experience I get or I have from doing projects, when things get tough, you always go back to the basics. So, which is why yesterday I was emphasizing that I really need to touch on this topic when we are all fresh, and because this is something, it's not just a class exercise, this is something that is going to be very useful even in your big data journey. So the cycle has 6 phases. The first one is the discovery, then data preparation, model building, model planning, communication of the results, and operationalize. So just like any software life cycle, discovery is like a feasibility study. And when you're doing a feasibility study in project management or in the software development life cycle or anything, you are trying to look at all aspects of the project. That is it doable? Is it feasible economically? Is it doable geographically? Is it doable in all aspects of feasibility? This slide is just showing a summary of what the life cycle is all about. Like I said, you always go back to the basics. Almost in all data science projects, you always go back to the basics, and it's iterative. It's iterative, and when you say it's iterative, is you don't say I'm done with this project, I can close it. There's always some data that you didn't use. Always, always, always. So when you present and you say I used all the data that was at my disposal, usually that is a lie, but we say it anyway to give the people who are listening confidence. But it's not a good practice as a big data analyst, because the process is iterative. You're always going to find new things. You're always going to get new things. You're always going to discover new types of analytics within the same data set that you've used maybe 10 times. You'll always discover something new. So these are the key roles for a successful analytics project. We have 7 people that are a part of a successful big data analytics project. First, we have the business user, and then we have the project sponsor, we have the project manager, we have the business intelligence analyst, the database administrator, the data engineer, and the data scientist. All these people have different roles in a successful project. However, particularly in Zimbabwe, you'll find that you are employed as a data engineer or as a data analyst, and you're doubling or tripling some of these roles. You are a business intelligence analyst, and you're also working as a data scientist, data engineer, and database administrator. But these roles are completely different. Maybe I hope to demystify what I mean when we look at the following slides to see what is the actual role of a business intelligence analyst, what is the role of a DBA, what is the role of a data engineer. So the business user is the person who understands the domain area. So this is the person. Let's say I've been hired by an organization to do data analytics for them. The business user is the organization. So they understand the whole area of the project. If it's for example a telecoms project, the business user will be, let's take for example, let's say it's Telecom. They understand everything about the field they're working on. How is the network configured, like base stations, what transceiver stations, what massage systems, all those things. They understand mobile switching circuits. They understand all those things. And then a project sponsor now is, sometimes the project sponsor can be a part of the team we are doing the project for. So this is the person who provides the requirements. And sometimes there's a third party, someone who is hired, and then they relay the message. But suppose it's a direct communication between me and Telecom. The project sponsor is usually the high-level management. And they say, okay, our technical experts are saying they're facing this problem, so we want to buy a system that does this. They just provide the requirements. Okay, we want a system that does A, B, C, D. We want you to analyze this data and tell us, when are we going to get our ROI? When are we going to meet this target? When are we going to recover this? When are we going to say we have acquired this thing as an asset? And when are we going to say we can dispose this asset? Usually top level questions that need to be answered by the project sponsor. So they give you the requirements and they tell you what they're expecting. We want to realize our return on investment in 5 years' time. How can we make that happen? So that's when now you start asking yourself, okay, what type of analytics do I need to do for me to actually tell them their return on investment? You can get it in 5 years' time as they require. Do I need predictive analytics? Do I need prescriptive analytics? Do I need to actually tell them what to do? Or do I need to predict, to say, no, with the way you are doing things, you will not likely meet the target? So those are two different types of analytics. Like I was saying yesterday, you can be an analyst, yes, but what the value you give to your clients determines the response or your value on the market. Then the project manager, just like any other project, ensures that we meet the objectives. This person is always looking at the Gantt chart. Are we meeting the set target for this stage? Are we meeting the set target for this stage? What are our target indicators? All those things, the project manager is responsible for making sure that whatever objective you have designed, they are smart, they are achievable, they are measurable. You know, when we say smart, specific, measurable, attainable, realistic in time frame, are we sticking within that time? Are the objectives realistic? What the project sponsor is saying they want, is it doable as per the business user?
Sorry, engineer, we are still on slide number 1. It looks like the slides are not moving.
No, it's fine. And now?
Yeah, they're now moving.
Okay. What I was explaining was not a part of the slides anyway, but it's okay if you can see this slide. Then the business intelligent analyst now. The business intelligent analyst is the domain area expert. So this is the person who has a deep understanding of the data that the organization has. If my project's user or the sponsor is given us a data set to work with, the business intelligence analyst is the person who is a subject area expert in that field, and they understand that, okay, I should have A, B, C, D as part of the data set. So why is this missing? Why is that missing? So they have an understanding. It's intelligence. I don't know if you're getting what I'm saying, but it's the intelligence of actually knowing what should be in the data and what should not be. If I get a data set like yesterday, the example we're doing here, M&E, suppose it's a wash project, water sanitation and hygiene project, and then you see these skirt size, shoe size. If I am a business intelligence analyst, the analyst in me should just tell me that this attribute is misplaced. Without even deep diving into feature engineering, I should actually know that this attribute is misplaced. But what I don't do, because I'm an intelligence analyst, what I don't do is completely disregard that attribute at first sight. What I want to do, because I have a deep understanding of the data, I have to dig deeper and say, why do I have shoe size? Why do I have waist size? Why do I have a shirt size in this database when it's supposed to be a wash project? Then the database administrator now is the one who creates the database environment. So database administrator, basarake ndiro create a database and documents the schema of the database. Database tables also. It has this stored procedures. It has this triggers. It has this views. It has whatever you are creating in your database. The database administrator is the one who actually knows. If it's my attributes, it's for traditional databases. If it's the modern databases, it is it's a document database, then what do you mean when you say it's a document database? It is this document, it is this collection, it is this, all those things. DB. Then our data engineer now is the one who provides the technical skills and assists data management, extraction, and supports analytics. ETL, data mining here. And it's not one data engineer issues. Extraction, transmission, and loading of data, moving data in and out of the database, analyzing, and all that. You need one data engineer. But in most organizations, you would find that the database administrator, when I created the database environment, is the same person who is manipulating, which is why we end up with a database that is completely spaghetti and a code that is completely spaghetti. Because I understand everything about the process flow. The reason for separating these roles when you're doing an analytics project is to make sure that everything has a flow. But when I'm an all-rounder, I will do my patches because I know that it's because of app. So when someone else comes and starts working on the same project, they will be puzzled. They don't know where to start, because when they press this, when they press this, and all that. So, well, I don't know, is it because of our maybe we are very economic? That's why we usually have an organization having a database administrator, being the data engineer, being the business intelligence analyst. But I've seen most organizations have started to separate the roles for the simple reason, long term, it's not a good idea when then you start having a high staff turnover. And the person who was tripling as an intelligence analyst and a DBA and a data engineer has left the organization, then you have a very big hole in the organization. So they've started separating the roles as they should be. They should always be separate because they create levels of abstraction. Database administrator, the data engineer should provide the data that is needed by the scientist. Okay, the extraction, transmission and loading, or transformation is other texts call it. Okay, I have done this to this database, it does this. Okay, I have created this analytics sandbox. Why have I created this? So that the scientist can actually provide a dashboard. So the data scientist is the one who provides analytic techniques and modeling. So when I need something as a data scientist, I go to the data engineer, please create this sandbox. Sandbox should have A, B, C, D. The data engineer knows what's in the database that has been created by a database administrator. So Aruziyama columns, Arimo, attributes, Arimo, and how the schema of the database that was created. So they create the analytics sandbox for me, and then me as a scientist, I then model or create whatever model I want to train. But if I'm the scientist, the engineer, and the administrator, and the intelligence analyst, my model is obviously going to be biased. The best way, if you want to get a very good model, is have many scientists. Some have many engineers, but not very recommended. Just have one or two data engineers, and then many data scientists. Because from the data scientist is where the innovation comes from, is where the different analytic techniques, it's where the skill, it's where you showcase what you know, what type of an analyst you are. If you are now at the data scientist level. So there are many life cycles that were created over time. There's the CRISP model, there's the Delta framework, and MED. All those types of analytics life cycle that were created. And then some of them, like the cross-industry standard process for data mining, is the one that was then modified to come up with the modern big data analytics lifecycle. It was simplified to give all this. And the big data analytics lifecycle has incorporated all the components of project management, Analyst Six Sigma, concepts SAA project management have been simplified in the big data analytics lifecycle, just to make sure that we are observing project management rules, and also we are observing software development lifecycle rules, and we are also observing cross-industry standard process for data mining. If you're doing anything to do with data, and you're observing all these policies, HIPAA, GDRP, data protection laws, you are observing all those things. So all of it, you find it within the data analytics lifecycle. So, like I was saying, the discovery phase is the one that is similar to feasibility study. So these are the type of questions you ask. Canonical discovery phase. Do I have enough information to draft an analytic plan and share for peer review? So remember, we said this is iterative, which is why you see this arrow going there and also another arrow coming back. Because the moment you ask this question and you say, do I have enough information? If the answer is no, then you're definitely going back to do it again. You keep doing your discovery until you find. And when I say good, this model can be applied anyway. I mean, as long as you're dealing with data, take for example, last week my digital forensics. Digital forensics means the penetration testing. Penetration testing, the first stage is similar to discovery. But it is to my tools to and it Kali Linux. Did we do Kali Linux?
Hello? Yes, we did.
Okay. Because I'm more direct, no confidence. Because I'm not on this again. Hello.
Takanzwisisa but inoda kuti gombozorevisa zvakanaka.
All right, it's fine.
Network.
All right, it's okay, it's fine. Discovery phase, the first two tools in Kali Linux, they are used for discovery. So, pese pasinenge tichishandisa tuma tools twese tichita sorry, just 1 second. Hello? Sorry, I'd excused myself earlier I'm just responding to Vanongo Chibunzo any audio. Okay, so like I was saying, take for example cybersecurity. How do you use the data analytics lifecycle? Kana tichita penetration testing, the first stage tinenge tichita the discovery. Of course, through pen test tinenge tichita information gathering, and then tichita maport scans, whatever, all those type of scan tools they say are under information gathering or Kali Linux. So that is the same thing. What I'm just trying to discover is, do I have enough information to draft an analytic plan? Do I actually know the architecture of this organization? Do I know have I been given the data set that I'm supposed to use? Those are the questions you're asking. And then when you then go to the data preparation, if the first question you're asking, the first question your answer is yes, then if I have enough information to draft an analytics plan, is the information good enough? Is the quality of that data good to build a model? So by data preparation, some actually call it pre-processing. Determining the quality of your data is when you employ machine learning. And when I say that's when you employ machine learning, that's when you start doing filter noise off, which if my data is incomplete, if my data is skewed, the statistical aspect of what all the courses you learned is where they fit per data preparation panel. And then when you then come to model planning, I now know the quality of my data, and now I start to think, okay, so what type of model can I employ? And each time you're starting about a model, you're now talking about supervised or unsupervised. I'm now saying, okay, do I want to do, if the data that I have is, for example, I need to know the address of Kuno Garavan. And then I just know, oh, okay, you end up with something. Okay, let me just check something. Do I have a whiteboard on this machine? No, I don't. Okay. All right. So when you know the labels of the data that you're classifying, for example, you're either a boy or a girl, what type of technique are you going to use, or what type of a model are you going to say, I want to use this model? When you know, you're either a boy or you're a girl. I know the classes. These we call them what? Classes. And so what type of model do you actually use? Can I talk machine learning and we start talking about, I know if you're a boy or you're a girl.
That would be a classification model.
This is a classification model. And so this is now how you start applying these concepts with how. Okay, so this is how type of stage number 3, model planning. And you process the noise. Unknown, maybe. Like Maslano, people try and conceal their gender, LGBT rights. And so you know gender unknown, because this is a social work-based project. We need to distribute clothes. So I need to know whether you're male or you're female. And if you're not willing to disclose that, then it means that I am disregarding that attribute. What? I don't want to disclose my gender. So the moment you have this only boy or girl labels, and you know, good, I know this is now a what? a classification model to whether, like, you don't know okay, which class should this belong to. Maybe they are coordinates, like I'm saying. All right, toda kudistributa zvinhu izvi, but all we know is kuti vanhu vanogara kupi. So how are we going to distribute? Build a model yedu step by step. Tatenga hembe dzacho dzatoda kunopa tine vakomana nevasikana, but to distributor say you now need to start looking at my algorithms for distribution. Algorithms like what's the easiest one? Like what's that algorithm? Salesman. I think Salesman algorithm, something like that. I don't know. The good distributor, my newspapers really. You look at that also in machine learning and say, okay, if I'm going to move, you're moving Salesman. I don't know. Does someone know that algorithm? Or does someone remember that?
Sorry, can you come again, engineer?
There is that algorithm that is used maybe by vanhu vemabin vanenge vachishandisa vanocollecta mabin. I want to move from point A to point B. Okay, I remember. It's called the traveling salesman algorithm. This one didn't. So now I know you're a boy or you're a girl. I know you're a boy or you're a girl. So I want to know kuti musikana uyu ari kugara kupi, mukomana uyu ari kugara kupi, and I know the coordinates. But how am I going to distribute that zvinhu izvozvo zvese zvandoda sei zvandoda kudistributa? So first of all, I have to figure out, okay, how are the coordinates distributed? So I take each person by person. I draw my X and my Y axis, and I say, okay, boy number 1 stays here, boy number 2 stays here, boy number 3, girl number 4, boy number 5, number 6, number 7, number 8, number 9, 10, chingodaro. And then when you have these coordinates, what do you have when you have something like this? What type of machine learning technique are you going to start looking at? Hello. What type of machine learning technique are you going to use? What type of model do you want to build?
Good engineer. Unfortunately,
Hello.
we can't see the whiteboard you're writing on. From the link you sent, it's saying access denied. It's asking for some rights, I guess.
All right, it's fine. Let me just fix that.
Thank you.
Do you have a class group email?
Hi, engineer.
Hi, Eve.
We didn't have, but we can create one should there be needs.
Okay, that's fine. Maybe I'll just stop using the whiteboard because it's for you guys to actually see it. Since I'm using my HIT mail, you have to be on my domain, or I have to add you one by one, of which that will take the whole class. Clayton, can you just mute your mic? Okay, it's fine. So I was saying, I'll just go ahead with no whiteboard. So I was saying, suppose suppose that all I have is the distance, and the distance is distributed geographically. It means I really don't know how to distribute, or even if because the I want to use the traveling salesman algorithm because it gives the shortest distance. I don't know unless these things are clustered in some way. So then we start applying my clustering techniques. So Nenda was there, okay, from boy 1 and boy 2, what is the distance between them? For me to say, okay, so you start now looking at what my clustering algorithms are equal, or unsupervised algorithms. You start looking at K-means, Manhattan, all those things, decision trees, okay, then alternatively, I can do this. Can you see my screen? My entire screen?
Yes, engineer.
Yes.
So can you see the whiteboard now?
Yes, you can see it.
Yes. Yes.
Okay, it's fine.
Yes.
All right, that's okay. So let me do this. You know, I always avoid to share my entire screen because things will just pop up. Sorry, let me just try and close things here. Just a second. Okay. So I was saying, suppose you have something like boy, girl, and you know, okay, people fit in these two classes. You're either a boy or you're a girl. And I asked, so what type of machine learning technique would you use? And someone answered, could you use a what? A classification technique. And why? Because we know the classes. And when you say classes, we mean I know you're either a boy or I know you're either a girl. These we call them labels, machine learning or classes. And then comes a situation whereby I now want to distribute, in the same project, I'm the big data analyst I've been asked, and I want to stage number 3 model planning. And I know what I did in a point in a go. Or Now I know that boy and girl are their addresses very distributed because maybe now when we are going to help these people, they are underprivileged. But it's not a project that is specifically confined to say cannot chipping. It's a project that is nationwide. And now I want to see, okay, so what's the best way I can distribute these clothes away from a donor? And how can I best utilize the resources I have? So you look for the address of boy one, maybe boy one anugarapanap, boy two anugarapanap, girl one, boy three, girl two, shingodar. And these are all coordinates or points. Zinogaran. Right. So what's the technique that I'm going to use to say, okay, this is how I'm going to distribute these people, or what model am I going to use? That's the question I'd asked. And I said, in this case, what you're going to use is the what? Clustering technique. Why? Because I know now these people are distributed within the same locality. These people within the same locality. So if I'm going to use a traveling salesman algorithm to distribute the clothes I have been given for boy and girl, I'm going to use a traveling salesman algorithm to measure these distances. Maybe I'll use Manhattan, maybe I'll use Caymans, what's the distance between this and this? Okay, so this place is closer to this. Suppose Tinikamwe foot Karipanap. Okay, so what's closer? Do I come from this point to this point, or do I come from this point to this point? All those things you need to know, because remember, big data analytics life cycle is an iterative process. So I need to know, can I trip a point panap, how do I go back? Can I trip a point panap, how do I go forward? Things like that. So that's how you then build your model, and those are the things you consider when you're on step number 3, model planning. Do I have a good idea about the type of model to try? Can I refine the analytics plan? And then from there, you then go towards to the model building stage. And then on the model building stage, I now say, okay. And so that visioning and everything, it's mystery, it's things we actually apply these techniques. But when we talk about it and we do them, sometimes we do, especially machine learning is fun. We do it because it's nice, it's enjoyable. But then how then are you going to apply it in real life? How then are you going to make sure do you utilize, because machine learning is meant to make life easy for us. Statistics is meant to make life easy for us as analysts. So how am I going to correctly implement it? So if you own it on, you can know, okay, because I need to explore, I need to know the security implications. I need to know if this data, if I don't have enumeration, escalation of privileges, discovery, information gathering, I'm coming up with my penetration test model. Then I have my data, I have scraped my data, I have it. The chance Kali line next to scrape my data. Now I have it. I'm going to prepare it using what techniques? Using my statistical techniques, filter data, mean, median, mode, t-square, chi-square, get the appropriate data that you want, and then come to machine learning and say, okay, do the supervised or unsupervised clustering or classification. What do I want to do? And then you actually build your model. Panapa, you can do as many tests as you can, because you have to have at least 3 models that you're willing to try, and then you come up with the best and reasons, justification as to why you chose that as the best model. And then Panapa model planning tab, which we are managing, we implement our machine learning for testing, the other 3 quarters for training, or I said it in reverse. But we distribute our data 1 quarter for testing, 3 quarters for training our data set, and then we input the original data at Sukudaisus. But okay, so is this model correctly predicting? If you decided with, okay, per model planning, I'm going to do predictive analytics. Is this model correctly predicting? If you said you're going to do prescriptive analytics, is this model correctly prescribing? If you said you're going to do diagnostic analytics, is this model correctly diagnosing? So you need to then do that. Then you ask yourself, is the model robust enough? If we failed, for sure. Because if it's not correctly predicting, correctly prescribing, or correctly describing, then something is wrong. You go back. If it's good, you're now communicating the results. And how do you communicate results as a data analyst? The reason big data analytics is now a part of every dashboards and interns or managers or directors, or they do not actually have time to read through a whole report. In as much as you'll have done a very good job, it's a very, very comprehensive report. But if you're not going to be able to present, if you're not going to be able to apply my visualization techniques, but okay, I'm going to communicate my results. I understand. If I see a graph like this, suppose what I know is there is a decline somewhere. For me, if I'm a CEO, if I'm a director, this is the thing that catches my eye the first time. Why do we have this depression? Why do we have this? If I see a graph like this and then I see something like this, or I just see something like this, just this, I want to know why. Why are we going the opposite direction? Those are the things that actually catch the mind of someone. If I see something like this in pie chart, I can easily interpret that, oh, okay, this is a greater percentage followed by this, followed by this. So we are channeling a lot of money to this project, but are we getting results for money? What are the quadrants saying? What is your regression model saying? I need to understand that. You put your quadrants there and you say, oh, okay, so these projects are... Is there a way to just clear off this word? Okay. You see something like this, and you want to know what is in this axis. So, suppose this is reward, this is risk. And if I see something in here, I say, oh, okay, this thing is low risk, low reward. So how much money am I supposed to put into this project? So these are the things they quickly understand. Oh, this thing is high risk, high reward as well. Okay, I want to build a greenhouse. It's high risk, but it's also high reward. Okay, I can just do my drip irrigation here. It's low risk, but also, well, relative. It's low risk. Maybe it's low risk, high reward, suppose. So which project am I going to start with? I have 4 projects that I want to evaluate, and then I hire you as a big data analyst. Tell me which project should I invest in. Greenhouse. Drip irrigation, potatoes. These are the projects I do at my house. And then I ask you, okay, second, this year, what should I prioritize? You start asking me, okay, what the data? This is a typical exam question. These are all exam questions. I usually structure them like this. And it's usually something Janina Tombotaram class or Lapis example. And then the questions you should start asking me on information gathering when I hire you is, okay, so last magama potato magambo maintain. Drip magambo maishansa ma sprinklers, maishansa drip irrigation. Okay, ko magambo tshengete. Magatenga ukuthi ayivenzele ukuthi kunovatic makaita si. And oh, what I muda kwisa drip apa muda ori ma papers mu greenhouse. Okay, magambo maita ere ma paper. What did you do? Did you sell them green, red, or what? That's discovery, the discovery phase of the big data analytics lifecycle. And then the data preparation, I say, Yeah, I did. But then you see, the thing is, the papers, papa in majuru, so akazojkiwa, or I did strawberries, and then so I really don't know if I get. Actually, I'm just saying things gibberish. You're not really understanding. So already you know what you have. What is it? What's the V that you have? What's the V that you have? This is a typical exam question. The V that you have is veracity. See, incompleteness of data or ambiguity in the data. I'm saying things that you don't really understand for you to build a perfect model. So you need to excuse yourself from those things should the model not be perfect at the end. So that when you reach at this stage, you're going to communication of results, you know exactly, okay, the reason why this model came up like this is because number one, the data that you gave me was like this. So given the data that you gave me, I managed to come up with such a model. And then operationalize now the last stage. We are now saying, okay, everyone is satisfied with the models that have been built. It's now time for us to actually implement and say, this is what we want to do. And then these are the times we start looking now and saying, okay, we have a successful model, but this model is scraping data off Twitter, it's scraping data off Facebook. Is this allowed in Zimbabwe, or is this allowed by Twitter rules, by Facebook rules? How do I use this information? So the corporate governance. If you're doing a project, your thesis, and you now are shut up operationalization, and you have taken a data set from your organization without their consent, operationalization will then say, me, I mark your dissertation, and I say, oh, I'm impressed, I really want us to operationalize this dissertation, or monetize this. Let's commercialize. We are talking about industry 5.0 now, 4.0, education 5.0, innovation and commercialization. And I said, oh, okay, Eve has a very good project, guys. I marked the dissertation, I supervised, and I think this is really a good idea that can be commercialized. And remember, all these projects that you do as part of your thesis are intellectual property that belongs to Chinua University of Technology. So, I just said it out there so that you don't face any challenges. I had a few students who then had challenges saying, no, but it's my idea and all that. It's your idea, but as long as you do it as a thesis, there's a page that binds you and say, this project was done in partial completion or in partial fulfillment of what all this work belongs to Chinua University, that will always bind you. So if you think your idea is worth something worthwhile, so I see your project and say, okay, let's operationalize this. We have to start now looking at the whole process, the way you discovered your data, prepared your data, planned, built, and communicated your results. And say, okay, the corporate governance, Joshua data rarapiwa ne praz, Joshua data rarapiwa ne potras, Joshua data, and what do they expect? At one point, I had one of my friends who did a project for ZESA a while back. And then later on, sometime, the parties and they don't know how to approach this and say, oh, okay, this person did this project, but then they used your data. It was a whole big confusion in there because you don't know how to approach this organization saying, but it's our data, build your own model, all this dynamics. That's why you should teach courses like corporate governance. Remember, I said hakuna course inonzi sinabasa in the degree program. Inesha yakatoisirwa course iyo. Then this is just giving a summary of what I've been explaining on this diagram. But discovery, you learn the business domain, what resources do I have, what is the problem, who are the key stakeholders, you develop your initial hypothesis. Remember, Tazuti, kanatafuta preparation, tapotanga statistics, and you to begin your statistical model, hypothesis you're trying to prove. Then you also identify your data sources. Remember, this is a typical exam question, but you'll never find me asking you, what are the sources of data? And then you come here and you say, oh, okay, our sources of data are media, cloud. No, it's in something like this that you actually say, oh, okay, I've identified my data sources, it's this. I know you're applying the skill that you learned. And then data preparation, You explore pre-process. Remember, I also said some call it data pre-processing. You design your analytics sandbox. What is an analytics sandbox? It's a separate environment from the actual environment. You are creating. Do I have a sandbox here? No, I don't. Do I have the app? No, I don't. Okay. Today, the machine I'm using doesn't have a lot of things. I'll try a different one tomorrow. So an analytics sandbox is something like, let me give an example maybe that you're familiar with. What was it? VMware. Your VMware, it's a virtual, you're visualizing a computer inside another computer. And why do we do that? For example, if you open a malware inside the VMware, it doesn't cross over towards to your main machine. So the same concept is applied in data pre-processing. You create an environment or an analytics sandbox such that whatever data you tamper with, you alter, you're not altering people's life system. You are not creating new variables in their live database. So you're creating an analytics sandbox. And this analytics sandbox, you create them on Hadoop or my frameworks say Hadoop. Let me just say my frameworks are not Cloud Data, Hortonworks, those kind of Hadoop frameworks. You create your analytics sandbox and you do your analysis there. Often, at least 50% of the data science project's time is wasted in this data pre-processing stage because it's iterative. You want to make sure that your data is as clean as possible. And then model building, you are now aligning the business objectives to the output. You're trying to achieve your hypothesis. Say, okay, for my hypothesis to come true, it's either you want it to come true or you want it to come false, depending on the type of analytics you want to do. Then model building. These are the questions to ask yourself. Does the model appear valid and accurate on the test data? Remember that model building, you can now see how these things are linking. For a successful project. As you can see, and in this case, when you start asking, does the model appear valid? Who is this person now? Who is this person who is asking these questions? We are saying this is the person who has a deep understanding of the data and knows that, okay, I'm not supposed to be getting a number. This is supposed to be a character. I'm not supposed to be, they're the person with the intelligence, the understanding, the domain area expert. So when you're building your model, you need that person side next to you and say, okay, this person, according to your intelligence, according to your domain area expertise, does this model appear valid? Does the output or behavior make sense? Do the parameters and value make sense? Does it make sense for me to be seeing eyes when I want to just know the name and then I see that this person is low? Avoid intolerable mistakes, something like that. Like, okay, and then I'm trying to say, what's the name or what's the age, and then you age, and then one becomes blind and it passes the model, is not validated. Are more data or inputs needed? What kind of a model chosen supports the runtime environment? Analytics, it's a company that has hired me. Do they, if I'm using Cloud Data or if I'm using, let's say, AWS, do they have the money to make sure that their system is residing in a cloud system like Amazon Web Service, or they want to use their own servers? They're using their own servers. And these tools that I'm using is whatever they are using, mainframe or whatever. So you need to understand all those things. Is a different form of model required? So you see, who answers the runtime environment is the database administrator. Who answers the behavior making sense is the business intelligence analyst. Avoiding intolerable mistakes is the database administrator, because they are who create variables in the database. But all these people are working on model building. So each person knows, each to their own. There's some level of abstraction. When they see this question, they know what's supposed to do, what is expected, what is supposed to be the output. And then communication of results, of course, this is now the visualization. This is the most visible portion of the process to the outside stakeholders and sponsors. Remember, I said this is what the stakeholders, the project sponsor, they want to know, oh, okay, can I return on investment? Whatever model you use, whatever technique, speak to me early 5, speak to me like I'm 5 years old. That's you know, someone said, if you can't convince me in the first 5 seconds of your speech, then your project is not worth investing in. So you then ask yourself, oh, okay, if I'm going to communicate my results, if I want to convince someone in 5 seconds, the best way to convince someone in 5 seconds is show them a graph. That is showing them that if you use big data, remember there's this graph here. If I want to convince an organization to buy my system, I'm just going to do this and just say, Nyasha analytics system, your company analytics system, and just do this. In 5 seconds already, I've convinced them. Then they will say, oh, okay, now tell us what is happening on that graph. But already with their layman, early 5 understanding, they've understood that, oh, okay, if I use Nyasha analytics system, this is the projected cash flow revenue, about 150 million. With my own, in 36 months, I'm only realizing about 50 something million. Okay, now I'm interested. 5 seconds. So that is the whole purpose of why digital visualization, why digital research coordinator, so that we get to that stage and we understand how to communicate results. Then operationalize the benefits of the project more broadly and set up a pilot project. So now you're now trying to say, okay, how best can we operationalize this project? How can we do our changeover? Do we run them in parallel? Do we do an abrupt cut off to your system, Nyasha analytics system, or we are going to run them parallel for a year and then we see which is giving us the best results? Or, you know, there's always that resistance to change. So by operationalize, you really need to know how to, you may have a very brilliant system, but if you don't know how to operationalize, if you don't know how to make people interested, it's hectic. I remember at one point, there's this security system called Okta that logs in. Let me check something. If you want to log in and it logs in your Google Drive, your AWS, if you're using Google, if you're using whatever, all of those other systems you're using, you just have your one login. Maybe with security, maybe they've come across my super keys, my super passwords, where you just say, okay, I need to store this password somewhere. Wait, do I have it? All right, it's fine. And then all your passwords are stored in that one super password. So when you lose your super password, you've lost all your passwords. Something like that. So you need to know how you're going to operationalize. Am I just going to make people that you get when you're operationalizing? You then need to say, okay, what are the key outputs for a successful analytic project? What am I really going to get? The business user maybe it's a PowerPoint of their system. The project sponsor a PowerPoint of what they were expecting. The project manager would show us to say, oh, okay, I've checked the timelines and we've delivered on time. The business intelligence analyst will do a PowerPoint to say, oh, okay, these are the things we avoided, these are the things we said, you know, just the intelligence part of the project. The database administrator will have to produce the code they use to create the database, and also if they have whatever, any other documentation they have to give. Because database administrator any code created the database and the documentation to say, okay, this view is created from this table. This stored procedure it was created for this reason, you know, so that when someone else comes, they know how to do that. There are tools that can actually do that. In R, you can use R Markdown. It writes a script for your whole database, and you just comment by voice to say, write that, and it puts. And then the data engineer and then the data scientists, you can see this is a dashboard analytics. This is analytics, transmission loading. This is a dashboard. You see, these are graphs, analytic graphs. So these are the type of things you just need to, business user tries to determine business benefits and implications. The sponsor wants business impact and return on investment. The risks business manager needs to determine if the project completed on time, within budget, and the goals were met. Analyst needs to know if reports and dashboard will be impacted and needs to change over time. The engineer and the administrator must share the code and the documentation of whatever transmission, transformation, loading schema that they've done. The scientists must share code and explain models to managers, peers, and stakeholders. So this is the person who then interfaces between these technical people and these non-technical people. In between them is a data scientist who should know how to present results in LE5. So, main deliverables: a presentation to the project stakeholders, presentation for the analyst, code, technical specifications. This is, in summary, the big data analytics lifecycle. I've taken about an hour to present this because it's a definite exam question, and you just need to understand the concepts so that when it comes as a case study, you know what is expected. Let me just check something here. I think I'll just I'll check and then I'll this is like the 2019 exam. This one had no case study. If you need these past exam papers, I can also always share them with you.
Yeah, most definitely.
Yes, we need them, engineer. You can share.
All right, I'll do that. I'll just create a Google Classroom and then I'll upload all those notes and the past exam papers. Okay, I'll check. I can't seem to find one right now. Okay. I'll just check and then I'll get back to you. I'll give you. Not a problem. Maybe it's on a different machine. Tools used in big data. You have to understand there are different processes in the big data analytics lifecycle, like we were saying. Pacha hosted what data, I don't know. Remember that you have to ask the question you put the runtime environment. The moment you start asking that question, where the processing is being hosted. So are we going to use distributed servers, cloud servers, Amazon, or are we going to use our physical servers? And where the data is stored, the programming model, are we using MapReduce? What are we doing? How data is, so all those, you need to understand tools that are used under each. What is the programming model? Where the data is stored? Where is it hosted? And MongoDB, my databases, Cassandra, you need to understand the type of databases to, okay, this one is a column database, this is a document database, this is a graph, all the types of databases, and say, okay, so if I see MongoDB, what is it? It's a column database. If I see Cassandra DB, what is it? If I see any type of database, what operations are performed on the data, of course, semantic processing or analytic processing, what you want to do. Then the risks of big data. unorganized data, the risk of having, these are the challenges that come with big data. Let me put them that way. As long as you have high volumes of data or data that is traveling at a very high speed, these are the challenges that you're going to face. You're going to have unorganized data, which means data that is very versatile. Like Facebook, they have images, they have text, they have videos, they have highly unorganized data, which means the challenge is that data needs to be processed in a timeous way. So this is risk number one. The data is highly versatile and it's always piling up each minute. It's overwhelming for enterprises to tackle such unorganized data and siloed data sets effectively. That's the challenge number one. Number two, storage and retention. Because of the rapid pace or the exponential growth that we talked about, data storage and retention is always going to be a challenge. These days, we are moving towards cloud-based storage solutions, but however, in the near future, it's going to be eliminated. We are still talking about cloud storage, but already some, Kunana, Facebook, they're already talking about edge computing, and we're still studying cloud computing because they realize there are challenges that also come with that. Then cost management. As long as you're moving your data towards the cloud, you have to think about renting or infrastructure as a service. The part of cloud computing, infrastructure as a service. You have to start thinking about that. Okay, we need to think about the initial cost of setting up and migrating costs, things like that. Incompetent analytics. Remember, we said you can be a very good analyst. Tested chapters are causing a big data analyst, but it's not all of us who are going to make money. Just like me, in my class, I did my MTech Big Data Analytics. I completed some years ago, and then big data was still, very fresh and very in thing. But it's not all of us who made. Some are there, some are here, some are lower there. There's always something that's going to separate us all. There's always something that's going to say, okay, this person is a good analyst or this person is not. Some may be very good at interpreting notes. You can be a very good analyst just by doing that. So you need to put yourself in the correct category of analytics. I think the next slide will explain that better. But what do I mean when I say put yourself in the class that shines or that illuminates the analyst in you? Don't try to be all knowing. You end up being a jack of all trades and a master of none. Stick to one thing that you shine best and make money from that thing. Don't say, no, because Ningi is doing analytics, so let me try and do that. You will be very disappointed. Then data privacy. This is where the cybersecurity aspect of things comes into play. The reputation of the organization. You can be a very good analyst, but organization ikakushedza ikakuti toda kuita rollover from SQL to Hadoop or from SQL to MongoDB or we now want to use Kafka or Flume or whatever. And you do that, and then they lose their data for some reason, or they are hacked if it's a bank. They will not look any further and say, it's because we're not protected or anything. These senior managers do not understand that, you're a data analyst, your job is not to protect the data. They will blame you and say, okay, you came with your Hadoop. When we had our servers in here, nothing was, people did not have their bank accounts diminishing and things like that. But you came with your Hadoop and you came with your Amazon Web Service here, and now look what has happened. Because Amazon itself, Web Service, has its own loopholes, it being a third party. So you need to think about data privacy. That's why yesterday I was emphasizing the reason you do digital forensics and ethical hacking is so that you understand the basic concepts, the security issues that come as long as you're holding someone else's data or you're manipulating someone else's data. You need to understand that, at least just the basic understanding. You don't need to be a guru in cybersecurity. You just need to have the basic understanding. Then also comes with the benefits. These are the challenges and these are the benefits. You identify the root cause of failures and issues are dealt with in real time. Full understanding of the potential of data-driven marketing or data-driven decisions. You are not just, You know, there's something that is called market basket analysis. I'm not sure if you did it in any other course. When you split business. Market basket analysis, you're actually trying to find the lift with, okay, place, the reason the shops are the way they are organized, the way they are, it's not just random. It's a statistical model. It's calculated and said, okay, what is the probability that someone buys cooking oil and salt? What is the probability that someone buys diapers and wipes? What is the probability that someone who buys sugar will also buy milk? What is the probability that someone who buys bread will also buy eggs? Those things are organized by statistics, not just by common sense. No, in common sense, we do that in tuck shop. But when you're now in an actual shop, it's a real statistical model that puts those things. So you're making a data-driven decision or data-driven marketing. You're not just copying at the big supermarkets with, one organizer. So you are doing something because you're analyzing it. Okay, from these transactions, the people who bought this thing actually did A, B, C, D, and this. Then generating customer offers based on their buying habits, improving customer engagement and customer loyalty. If someone is buying a lot, okay, let's do this. Let's give these people my bonuses or my promotions. On my share, used to do that. Then reevaluating risk portfolios, personalizing the customer experience. You say when you go on a site, you're asked, do you also want this? Do you also want, if you go on B4 and you start searching for a fit, they'll also start showing you all those hatchbacks. If you go there and you start searching for my ML, they'll also start showing you my Volvo, my XC, you know, my SUVs. It's not because power fits and they started showing you small cars because they've thought you don't have money. No, they're just trying to improve your customer experience by saying maybe you're looking for something small or maybe you're looking for something big. And they personalize the experience based on that, adding value to online and offline customer interactions. Now, this is a tech company that deals in software engineering and cybersecurity. A new director who was recently appointed wants to improve the company's engagement of employees across their centers of excellence to drive innovation, research, and university partnerships. So there's a company, Riptech Consultants, that deals with software engineering and cybersecurity. They've hired someone who is you, and you are required by the directors of this company, by the CEO or whatever senior management of this company, to say, okay, this is our company. We know now universities are doing this education 5.0 and Minister Murray is talking about do innovation, do research. We want Riptech also in that space. So what can we do? What partnerships can we do with my universities to drive this tech company? That's the job of a big data analyst, to say, okay, how do I correctly position this company for the open market, both for newcomers and for bigger players? So explain how you accomplish the following tasks using the big data analytics lifecycle. Store formal and informal data. How are you going to do that? You now need to start thinking about my cloud service. Okay. If it's formal data, you also need to start thinking about if it's formal data. If it's informal data, what are the security implications of that data? If it's formal data, how are you going to pre-process that data and store it? What are the processes you're going to follow before you actually say, I'm storing this data? Track research from global technologists. I have researchers in Riptech Consultants. So how am I going to track that research and match it from the global players and say, okay, I think our research is going towards the right direction? There's something that is called the I don't know if you've heard about this, the Gartner hype cycle. Let me just take the 2021. Now, look at this thing. When I say when you're tracking research, this is also going to be helpful for you. Okay, this is the Gartner hype chart for emerging technologies. if you have a stable internet connection, you can just check that on your phone or after this. And now, if you see this Gartner hype cycle of emerging technologies, kuna knows my innovation triggers, then the peak of inflated expectations, and then the trough of disillusionment, slope of enlightenment, and plateau of productivity. Kana tichiti innovation trigger, anditi zvakafana nevanhu vakatanga kuadopta the blockchain technology. Those are like the innovation triggers. Blockchain is a technology, anditi kune vanhu vakatanga kutoshandisa blockchain kudhara way before cryptocurrency came into play. And then at the peak of inflated expectation is like when blockchain became, cryptocurrencies, Bitcoin, Dogecoin, all this Ethereum, all this, that's the peak of inflated expectation. And then when you see, the Bitcoin that's the trough of disillusionment. When you're saying, okay, we had so many expectations and hopes, you drive something beyond its own capacity, and then it then comes down. It's a slope that is very painful. But then from there, you have what we call the slope of enlightenment, where the technology is a stable technology now. And this is its plateau of productivity. It cannot go beyond this. It's now just flat, going like that. So if you want to be a good data analyst, and you can check the Gartner hype cycle for data science and machine learning and see, okay, so what is the thing that is making a lot of noise in 2020, so that you project yourself, you correctly position yourself. My connection is very slow. I'm very sorry. I'm not get it today, so but anyway, just check that out, and then you will see. Just check Gartner hype chart for data science, which you can see. Now we're talking about quantum machine learning. It is more than 10 years. As of July 2020, it is more than 10 years before the technology becomes a thing. So if you really want to correctly position yourself, you can start doing it on peak of inflated expectation, and you can make a lot of money, because this peak of inflated expectation, you reach it in 5 to 10 years, 2 to 5 years, and you just follow this. Okay, what are the technologies that are coming? Federated machine learning is a blue dot, 5 to 10 years. Self-supervised learning is a blue dot, 5 to 10 years. Reinforced learning, transfer learning, language model, large-scale penetration, AI-related, citizen data science, auto machine learning, augmented machine learning, deep learning, deep neural networks. You correctly position yourself for a time to come. So if you pick a technology that has more than 10 years or 5 to 10 years, you make sure you are relevant for the next 10 years. For example, when I did big data analytics, then I just knew, okay, my imaging technologies, I knew I was going to be part of the panel, definitely. So it's in that phase that you actually know, okay, I'm it, but it's only going to last but a short while. Why? Because I picked a technology that had 2 to 5 years, and it only lasted me about 2 years before things started, and there were a lot of big data analysts or data analysts on the market and things like that. So you need the same thing for you guys. You need to make sure you don't make the person. You need to position yourself to say, okay, this organization is going that way. So what's the technology I can learn now? It doesn't necessarily mean it has to be a PhD, but I'm saying it's a technology you just need to learn because you're a data scientist or you're a big data analyst. It's a technology you need to learn so that you stay relevant for the next 10 years. So you look at this hype charts, Gartner hype charts, and say, okay, what's the technology that is going to trend in this domain that I've picked? And you start just learning bit by bit about that technology. There's certifications. Okay, what is it about? How do they use it? And things like that. Text analytics, predictive analytics in things. But now when you talk of predictive analytics, every organization is doing predictive analytics. So don't just pick something that lasts you only 2 years before you become obsolete. Mine the data for patterns and insights to improve the team's operation and strategy. So this is an exercise that you have many groups and data marketer for digital forensics.
Yes, we have.
So you're going to do this exercise in groups. Mind you, one thing I really don't like is I don't like people who copy the works of others. When I mark your assignments, I mark question by question. This is what I do. Can I do question number 1? Do you remember question number 1 for everyone? And then question number 2 for everyone. So the likelihood that I will remember, can I mark on the same day, likelihood that I'll remember that I've read this before is very high. And then I usually get calls. I'm very sorry, because I will just divide the mark. Whoever was the original author and the person who copied you will get the same mark. So I usually get calls. I'm sorry, I took assignment and things like that. And honestly, time test. So let's just do things the way they're supposed to be done. Just make sure you do your own assignment. If you ask for an extension, I'll always give you an extension as long as it's not towards the period of exams. I prefer you ask me for more extension and do things the right way than to copy each other and submit something that you've copied from someone. So you go through this PowerPoint, the hints, these are just hints. So you do how you use the big data model for this exercise. This is just a hint. So I'll share this slide with Eve if you distribute to the class. Tomorrow morning I'll create the Google Classroom and then I'll share it there and all the notes that we're going to use. So for introduction, this is all. This is chapter 1 and chapter 2, 54 slides that we did. I don't know if there are any questions before I close the slide and just introduce the next chapter for the next 20 minutes since we finish at past. Are there any questions? Silence, I'm assuming none. Okay. Topic 2, which covers chapter 3 and 4, we talk about the features of big data. We talk about issues of security, compliance, audit, and protection. So what's the content? Big data security analytics. We're not going to talk much about it because we've been singing that, because engineering, you asked me to say, please, you need to rubber stamp why ethical hacking and digital forensics is important. So that's why you notice that most of my examples I've been trying to talk about security a lot, in as much as this whole unit was dedicated to just security. So I'll be just rushing through this because we've already covered much of it. Sometime in 2017, there's an organization that is called Rapid7. They do analysis of ICTs around the world. And Zimbabwe was number 1, top 10 most hackable countries in the world. That's a statistic in 2017, although we are no longer number 1 right now. But this was the trigger of the cyber bill, the data protection law, and things like that. This was the biggest trigger to say, okay, we had an explosion of web designers who were using websites with just HTTP, with no secure security layer, the SSL, which gives the HTTPS. And that alone made sure that the country is very vulnerable. And then because also we don't have our own satellite, that contributed also a lot. The fact that you buy or you rent infrastructure, you're always given infrastructure that is not really the best. Yesterday I was saying, what are we protecting? I just added this slide so that I re-emphasize what I was saying yesterday. Traditionally we had the processes, we had the technology and the people. Now we have come to realize that, it's a eureka moment. What all those people, processes, and technology are trying to protect is the data. And that's why data has become a good thing. We talk about data sovereignty, we talk about data colonization. Back then, people used to come and then say, this land is now our land, move away from this land, we are now the owners. But now, he who has data has money. Data is the new oil. If you look at Mark Zuckerberg, if he was using the Gartner hype chart, I don't know, whatever technology is using to predict the future, I have no idea. But look at the way he started and look at where he is going. He made sure that every new entrant onto the social media network or onto the social media buzz, he would pay lots of amounts to get that technology. And what is he buying? For example, Yahoo. People last used Yahoo a long time ago. I don't know my class Yahoo, but Yahoo was a technology that my dad was using Yahoo email and Hotmail and things like that, and Mark Zuckerberg bought. But he knows that this generation, this breed of social media savvy people are not using Yahoo. So what is he buying? He's buying the data. He is buying my father's data to predict the things that I like or things that he likes, or predict, okay, so I think in life these people are sort of here. So you need to understand that when you give out your information to people, you think, it's just, okay, it's a website that says, okay, you want to, for example, you want to register for a conference, and then you are asked, okay, how many kids do you have? But I mean, what does that information have to do with me attending a conference? So you need to understand now, because you're a data analyst, someone is harvesting data. Because if for example, I myself, when I want to create a data set, I'll always create a questionnaire that I know it's very interesting to answer. How many relationships have you had? Nowadays, you actually see my questionnaires, just for fun, fun fact. In organizations that know Shandira remotely, we have, for example, on a Thursday, we have what we call Fun Fact Thursday. And you have to say something about yourself that no one else knows. I mean, why do you do that? Someone else in the organization is using that information to do something about you. So you don't just, when you now understand all this concept, you don't just give information willy-nilly to people. You are at the same time security aware or cyber security aware, and at the same time you understand that data is the new oil. We are now fighting over data. Nyaya ye Cambridge Analytica, nyaya ye Oxford Analytica. Sakunda, there was a flyer that was going around sometime in 2018. Sakunda ye Oxford Analytica, Zimbabwe election, presidential elections. All those things, they are just there to get data, to get to know something about you. So we have a new tool that is called Big Data Security Analytics. I talked about it yesterday. What do we do with Big Data Security Analytics? We are trying to do risk management. We are trying to do highly intelligent risk management. That's what we're trying to do. We're trying to visualize. We're trying to categorize our threats. Okay, what is this? It's a worm. For example, I didn't want to do this, but let me just quickly do it. Risk management, these days we have a lot of new tools that are coming. So now, for example, you put the risk here and you classify the level of risk, and then you try and visualize the risk and then the monetary impact. So what is the risk? What is the risk to an organization? I'm again going to use an example. We can get hacked. Sorry, you can't really say I'm not using a stylus. I'm using the mouse. We can get hacked. Okay, what type of hacks do we have? What type of hacks do we have? We have viruses. We have a worm. We have a ransomware. We have a ransom worm. Ndizvo handiti zvatakadzidza kudigital forensics. If we are attacked by a virus, what is the level of the risk? What is the level of the risk? In your thinking, this is a typical exam question, so if you participate, it's even better because you will remember. If you're attacked by a virus, what do you think is the level? 1 being the lowest, 5 being the highest.
I think 2.
2. Why 2? Why 2?
I think it to recover from a virus attack, and also and also you might lose a little bit of data, not much of data, if you are attacked by a virus.
Okay, it's easy to recover from a virus and then if it's a worm, maybe we put it on a 3. If it's a ransomware, maybe on a 4. If it's a ransomware, it's probably a 5. Why? Because it means it's anti-ransomware. We know what it's a ransom plus a worm. It's propagating through your network, and each and every computer is now logged, and you need to pay those people. So what does that mean? Because whoever is the big data analyst, you have put this, but to the manager who needs to visualize and put the monetary value, you need to simplify those things, and you put a table like this and say, okay, if you're going to visualize this thing, it means virus rikakwata kai. We have this much money, we probably lose this much. If it's this one, it's probably going to be what? If we have this one. But if it's a ransomware, tapera, apasina company. So in terms of money, maybe we've lost 30,000 here, 40,000 here, 50,000, and maybe we've lost all our 100 million that we had. If we had, let's say, 1,000 connected devices in the organization, and they've all been locked by a ransomware. So those are some of the things you need to start doing when you're doing risk management, intelligent risk management for organizations using big data analytics. You're visualizing the threat and you're giving them graphs that are easy to interpret. L5. Visualizing the threat, I've already covered this. It's intelligent risk management, the complexity of cyber attacks, understanding the stand of trend. Then penetration testing. You also need to do all these 5 stages: and planning, scanning, gaining access, maintaining access, analyzing, a new escalation of privileges. They all follow the big data analytics lifecycle. So it's basically just giving an insight of the business infrastructure and the processes. Challenges of big data security. Number 1, we don't know how to protect the transaction logs. And it's because the size of the data increases continuously, and you need to protect those logs without actually doing away with the fact that you need to be able to analyze the logs at the same time. So whatever, because security, even you don't even know how to use it because it's too secure. So you need to make sure that whatever security you put, it's scalable, it's not very robust or complex. It serves the purpose, so to say. Then validation and filtration of endpoint units at the edges of our network. What are we going to do to protect the data? But we are trying to protect what's inside our network and what goes out of our network. So you need technologies. Nobody grouping that the technology pillar of protecting our data. And securing distributed framework and other processes we are talking about when I may produce, we'll talk about that tomorrow. And then securing data in real time. If it's streaming data, if I'm scraping data off Twitter, I need to be able to know. Screenshot association. So it's very difficult to do anything about trying to protect data that is moving in real time. Post something now, 5 seconds later, someone has already captured the screenshot of what you said. Post the wrong audio in the group, even if you say delete for everyone, someone is using WhatsApp GP, they have that information. So you really need to know how to, it's like in the age of big data analytics, securing and protecting data in real time is the biggest challenge. We need to know the technologies, MQTT, Kafka. You need to know which streaming technologies are used to secure data correctly. Protecting access controls and encryption, data provenance. Are you aware when you're talking about data provenance, you need to make sure that the data is authentic? Have you observed the authenticity, the integrity? The CIA triad here, confidentiality, integrity, authenticity, and availability. You need to make sure you know. That is what we call data provenance. We need to know. Remember, I said there's a new type of colonization now. We are being colonized. We call it data colonization. So you need to know, okay, this data that I'm using, where has it come from? Granular auditing, recognizing the type of attacks or activity, what has been taken. Because when someone just takes data and they don't change anything in your system, it doesn't mean that you haven't lost something. Because if they can use that data to their advantage, then you have lost something. It's difficult to quantify your loss when someone has just breached confidentiality. That's why you find it, example, and then, we really don't know what he lost. Even if he recovers the iPad now with all of its contents, what he lost is far much more important than the value of the iPad itself. Granular access control, privacy protection. This we will, big data security strategy, the data sources output. Okay, we will continue on this tomorrow. I think for today, that is it. Tomorrow, maybe I'll just do one practical to show the example that I was talking about, your market basket analysis. Maybe we'll try and do, I'll see what we'll do tomorrow. Then I'll also give you, if you can just send me my groups, Amurkushan, Saku, security, just send me so that I allocate my topics. Tomorrow I'll also give you your assignments and the due dates. I'll post them on the classroom.
Noted, engineer.
All right. I think for today I'm also a bit saturated. I think for today we can end here, and then tomorrow we can start on the security strategy. This is now chapter 4, and we'll do chapter 5 and 6 as well tomorrow, and a few practicals. I would have said, please install Cloudera or Autonots or whatever Hadoop framework you think is okay for you. Please install R, but I know R you already installed because you used it. I would have said, please install. But we are learning with the new normal. Even if I say install now, there's no time for us to do that here. So I will share some videos of practicals I have done, and some that have been presented by past your seniors. And some you will actually do them because we don't have time to actually do my practicals. It will be your practical assessment mark. So it's to your 30% of your theory coursework and 30% of your practical as coursework, and then 40% your final examination. And of that 40%, 20% is compulsory, is a compulsory question, 20% you choose. I don't know if that is clear.
Yeah, it is, engineer.
Okay, so that is fine. I think for today, that is it. Have a good night, and we meet again tomorrow.
Thank you. Have a good evening.
Thank you.
Thank you.
Good night. Bye.
Thank you.
Thank you.